Hello everyone. Today we're going to look at a little life hack, or I guess it's a programming hack in this case, of how to hopefully make your life easier, and that is adding an internal keyword. If you've used C Sharp, you'll recognize the internal keyword as being something that you would use with a library where it's publicly available for the library, but any outside program or executable or other library, I should say, is unable to use those functions or methods if you're using the C Sharp terminology. Now, I believe Java also has something similar. However, I do not recall what it is called. So if we look at our executable here, it's very simple. We're including our library, and I like to aggregate all of my headers together, or I guess it's more of a combiner. It doesn't actually aggregate all of the text, it just merely includes all of those header files. The reason I like that is I don't like, if someone's using my library, for them to have to know all the internal um, implementation or header files that they need to include to get the job done. So this file basically takes care of all of that for them. And that's just a personal preference that I have. Now you'll notice that there's a warning here, and the warning is that we're converting a string into a character array, and we're not going to worry about that. Yes, it's not the best practice in the world, I'm sure, but we're just trying to show the point of protection levels here and adding an internal keyword. So if we run this real quick, we can see that we have an exit code 0. All of this is being tied together with CMake. If you would like to know more about making and using libraries, I have a video on that, so you can check that out. I'm not going to get into the details of how CMake is connecting these two things together in this video. Anyway, if we run this, you can see it says testing, and it goes to a new line, and that's all great. So without further ado, let's look at what our library looks like. Inside output, there is one method or member function. If you're a C++ purist, and this is what we want to be able to call. It outputs text, so on and so forth, very simple. And then we also have a utility, which in a larger library, this would have a whole bunch of utilities that you want to use, and currently it is marked as public. And the reason for that is so that the output can find it, because the implementation says to call it. Now these are static methods, static member functions, if you like. So that's why we don't need to actually create an instance of an object. But if you're watching this video, I'm assuming you already know the difference between static functions and member functions that are not static. All right. Anyway, is there a way around this? Well, of course there is. One way to get around it is we can indeed mark this as private, and then we can include a friend class, and this will compile just as well. We got our exit code of 0. However, a lot of people don't like to use the friend keyword, and the reason for that is you need to remember to include every single time something's a friend, and if you get rid of some of your classes, it might still say that there's friends out there and they're really not. So that can be a little bit of a maintenance issue. However, if we don't have that friend, we get build errors because it is private. So our goal here is to implement an internal keyword where everything inside of our library can access this method, but not something outside the library. In this case, the main function in our executable. So let's get into it now that we have enough exposition of explaining all the characters and casts of our program here. We're going to add a new file, and we will call it, let's use start internal, because we are going to need an end as well. And in our start internal, let's put in our header guards. I'll call this library, start internal, HPP, define it, and if. And what we'll do in here is we will say that if library HPP is defined, which is here, this is where this would be defined. So this will only be defined from external sources. I would assume that if you are implementing your own code that you're going to use your own include or header files out of the include folder and not use the little cheat sheet here. So that is the premise, that external executables, libraries, all that will use this nifty little helper file, and the actual library itself will not. And the reason for that is if it's defined, what we're going to do is we will define an internal keyword. I put an underscore in front of it because there are things within the standard C++ library, enums and such, that actually use the word internal. So that little underscore basically shows that it's a macro and that we're doing some special magic here, and it won't break the standard library or anything like that. Anyway, it will be defined as private if that file is included, and if it's not included, what we will do is we will define internal as public. And then we'll do an end if here. So what will happen is it will be basically the same thing as saying public from inside the library, but from the outside it will be marked as private. Now we have to include our start internal, and we will include that also under output, even though we're not going to actually use it in here. I imagine you would want to use it whenever you can if you choose to use this paradigm of programming. So now we need to add an end internal, and the reason for that is if you were to include a whole bunch of other libraries and things like that, you don't want to be defining that internal keyword because they might be defining it some way differently, and obviously we don't want to just pollute the namespace basically with all these macros that we don't want to use, so or other people to necessarily use. So we need to make sure that this is the last include. So if we were including something else, all of our other includes would happen up here. And the reason for that is we only want this internal keyword to basically exist for this class. Now I said we were going to need an end, so let's do that. Inside the include folder here, end internal. And we would quite simply put it here, include end internal. All right, now we actually need to make it do something. So what we're going to do is if this start internal is defined, then our internal keyword will exist. So what we will do is we will undefine our internal keyword. And so that you can call this across multiple classes and this isn't always existing, we also need to undefine that. And if. All right, we're almost ready to test. So now if we look at our utility, you can see it says that it expands to private, and that's just because Visual Studio Code actually is looking at all of these files here and it realizes that this exists. Unfortunately, it's not quite smart enough to know that it is public actually at this point, unless it's being accessed from externally, but let's just build it once. You can see there's an exit code here of 0, and if we run it, that's all fine and dandy still. But let's see if we try to access it externally. So we have our utility, and it was called internal print. If we build it, you can see that it says it is private. So what we have done is inside this library, anything marked with internal is public to the library, and anything external to this library, it is marked as private by using this nifty little file. So besides making this easier for everyone, it allows our internal keyword to work. So that's all that I had for you today. I hope you enjoyed these little C++ hacks. It's always fun making the C++ language do things that it wasn't exactly designed to do, so that you can program the way that you want to program, and that's really what programming is about. Unless you're doing it for a job and they have all these standards, at that point it is to make your bosses happy. Anyway, I hope you enjoyed this video. If you like this type of content specifically of putting hacks into C++, please do like the video. It lets me know you want to see more of these little hacks. And if you like the content in general on this channel, please consider subscribing so that the YouTube algorithm will get it out to a larger audience. So again, thank you for watching, and we look forward to seeing you in the next video.